All right, so we're going to put these skills of multiplying and dividing fractions in practice today as we look at lesson 3. Now, we've done these problems before, right? It's a ratio table. We need to know, what do we do to multiply? What do we do to go from here to here? Well, let's see, to go from 1/2 to 1, we're multiplying by 2, right? So let's do the same thing for that 3/4. What does that 3/4 multiplied by 2 look like? Remember what to do here? We don't have a fraction. We make it a fraction by putting it over 1. And then again, we can multiply straight across, or we can simplify first. 2 goes into 2 once, 2 goes into 4 twice, and now multiply straight across would give me 3/2. 3/2 I'm perfectly happy with as an answer. If you want to change that to 1 1/2 or 1.5, I'm okay with those as well. Now we want to think about, remember this, how do we go backwards? If we go left to right by multiplying by 2, we would go right to left by dividing by 2. So let's see, that's 1 3/4 divided by 2, also known as 1 3/4 is 4 times 1 is 4 plus 3 is 7/4. Divided by 2 would be times the reciprocal times 1/2, which would be, if I multiply across, 7/8. All right, you guys finish up those next couple of boxes. We're going to answer lesson 3-2. We have our methods here. This is showing Kieran, our old friends Kieran and Priya here. Kieran's saying he's going to multiply like this. And Priya says she can do this a little bit differently. Question is, what do you think Priya's method is? Also, can you fill in that box for me? So take a minute and fill in the box and answer the question. So we have another question like this, and we could use our Tyler swims. Here's Tyler again, swims at a constant speed 5 meters every 4 seconds. How long does it take him to swim 114 meters? We could do this with the ratio table. I want to show you a different way, slightly different way. It involves this phrase called cross-multiplying. It's another quick, easy way to solve any kind of ratio. So cross-multiplying involves setting up a proportion is 2 equivalent ratios. So what I'm going to do is I'm going to write 2 different fractions. 2 equivalent fractions. So I know that Tyler goes 5 meters in 4 seconds. I'm going to just put little labels here just to remind myself what I put where. Meters and seconds. Now in that other fraction, I want to put the same thing in the right place. So I put meters in the numerator. I'm going to put his meters in the numerator here, the 114 meters. And then this is what I'm looking for. I don't know what that is. I could call it question mark, or I could call it X. Let's introduce a variable here. Now the little M and the S that I put here, they don't mean anything. They were not variables. Those were just labels. All right, so here's what cross-multiplying looks like. And it's really the same thing we've been doing, but we kind of shortcut it a little bit. What we're going to do is, see these 2 numbers that are diagonal from each other? We're going to multiply those together. 114 times 4. 114 times 4 is 156. Sorry, 156. And that's equal to, that's the same thing as 5 times this unknown number, 5x we'll call it. Now the question is, how do I go from 5 times what gives me 156? Well, I solve that by dividing. I'm going to divide by 5 and divide on the other side by 5 as well. And if I divide 156 by 5, I get 31 1/5, or 31.2, I believe, seconds. Okay, so we can do that using, we call that a proportion. So let's see, same thing with the next question. A factory produces 3 bottles of sparkling water for every 8 bottles of plain water. How many bottles of sparkling water, that's our unknown, does the company produce when it produces 600 bottles of plain water? So let me set up an equation for this. 3, and I can do this anyway, 3 over x equals 8 over 600. I just have to have the right piece with the same right piece. The 2 that are diagonal from each other I'm going to multiply together. always. 3 times 600 is 1800, and that's equal to the other two that are across from each other multiplied together, 8 times x. And then to solve, I'm going to divide by 8. Divide by 8. So do that out for me, figure out what that x is. Now for this next question, there's no ratio table there. Let's see if we can do this by just doing the equation. So we have blue paint is mixed with white paint. All right, so we have 1.5 quarts of blue paint. I'm going to just put a little blue there to remind myself, is mixed with 5 quarts of white paint. How much white paint would you need to mix with 4 quarts of blue paint? So I know the 4 is going here and my x is going here. I'm going to remove that little blue and the white. So I'm going to multiply. Again, the two that are diagonally across from each other. 5 times 4 is 20. That's equal to 1.5 times x. I can do 1.5 times x if I want to. And now solve by dividing by that 1.5. So divide that out for me. So it's just a quick, easy way to set up a ratio problem. Finish that up. This activity 3-4, we get some complicated numbers here, but we got this now. We have a way to solve this. We're talking about Lynn and Tyler, and these are two separate questions. Lynn runs 2 3/4 miles in 2/5 of an hour. Tyler runs 8 2/3 and 4/3 of an hour. How long does it take each of them to run 10 miles at this race? So we're going to do this separately. We have Lynn with 2 3/4. That's her miles, or his miles, over 2/5 of an hour is the time. And what we want to know is how long will it take Lynn to run 10 miles? Well, the miles was the number I put on top. I'm going to put my 10 there and my x there. For Tyler, same thing, just different numbers. We have the number of miles he ran, 2 and 8 2/3 in the top, in 4/3 of an hour. How long will it take Tyler to run 10 miles? So we're looking for our unknown x, okay? So again, cross multiply for me. We're going to do 2 3/4 times x equals 10 times 2/5. A little bit trickier with the numbers here. Try those out. And then for Tyler, 4/3 times 10 equals 8 2/3 times x. See what you can do with that. And then try number 2. It's a similar kind of question. For each one of them, we're looking for 100. How much should they mix with 100 cups of water? All right, so try that proportion. If you can't get it, try it in a ratio table. All right, I want you to read through the lesson summary and do the practice problems that you were assigned. Okay, have a good day, everyone. Bye-bye.